Well, welcome to our course, Computer Architecture and Design, CS360 and ENGR 360. I wanted to give a little bit of an introduction before I get into the details here. And so, first of all, we're going to be using the textbook Computer Organization and Architecture. So this is a pretty comprehensive text, and I think you'll like the way that the material is broken down. And so in way of introducing the material, here's a nice way of viewing it with the contents of the 21 chapters that we'll be covering. And so there are six different major section and introduction where we'll get a chance to get familiar with some basic concepts and computer evolution, seeing how things have developed over quite a number of decades now. We'll then introduce performance concepts. And so that would be the first thing, just give some basic orientation to computer design, computer architecture. Then we'll get into a top-level view of computer systems. And so we'll have a variety of chapters that will give you a lot of sense of how things work. We'll get into some of the memory, a top level of computer function and interconnectivity, input and output, and then thinking about the operating system. So that would be the second major portion. Then we'll get into arithmetic and logic. And so how does a digital computer actually function? And so the things that it is reduced down to is the digital logic. We have to be thinking in terms of, well, what is the numbering system? We'll be talking about binary and hexadecimal, especially how computers go about doing arithmetic. And so that would be important as a building block as we move along. Next, we'll get into the instruction sets. And some of you may not have any experience with assembly language, but we'll get some introduction to that as we're going through this course. And hopefully this material will help to make it less alarming and hopefully kind of cool as you start to see how this works. And so we'll talk about the instruction sets and how we go from a relatively low-level language to the specifics of how a processor actually thinks and does the various things it's called upon to do. We then have this last major section where we focus not on the computer system, but on the central processing unit, the CPU and the various parts that are part of that, including the arithmetic logic unit. And so I think this will be a quite important part of our course. And finally, we'll talk about some of the various ways parallel organization has been done as computer systems continue to evolve. So that's just a rough introduction to the material, and then I'll just finish with just a couple other slides here. So as we're starting to get familiar with design principles and implementation issues of contemporary operating systems, it's useful to be looking at, well, what are the real architectures that are out there? And there's basically two. And so we'll be looking at both of those. Our project work will be focusing more in the ARM architecture with the emulator that we'll be using. But basically, we'll be thinking about the Intel x86 architecture. It's widely used for non-embedded computing systems. And so just tracing the evolution is quite amazing. So this is an example of a complex instruction set computer, or CISC. And it does have some RISC features, and RISC stands for Reduced Instruction Set Computer Features. So that will be the first thing that we'll be covering as we're going through the material. And then the second one is the ARM, which the acronym is either the Acorn RISC machine, and RISC is pointing back to the Reduced Instruction Set Computer, or Advanced RISC machine. And it is used widely for embedded processors, cell phones, iPads, various tablets, remote sensing equipment, and many other devices. And recently, there's been a trend for a variety of laptops that are starting to use an ARM-based computer processing approach. And so ARM is essentially a reduced instruction set computer, and there's various architectures that the ARM has made available. So that's an introduction. These slides are made available for folks that are in the course. Please do not share it or others with others or post it on the internet. Those are the things that the publishers have requested. Okay, thank you very much. That's just a little bit of an introduction I wanted to provide.